Owners of diesel-powered vehicles are all too familiar with change. In 2007, the EPA tightened regulations focused on particulate matter, or the trace amounts of solid unburned diesel fuel. Now in 2010, new regulations focus on NOx, calling for an 83% reduction in nitrogen oxides, gaseous pollutants formed during diesel combustion. In order to be in compliance for 2010, there's one decision to make: simplicity or complexity. Over the next few minutes, we'll take a look at the two different approaches to 2010 emissions regulations. First, we'll take a look at what our competitors are doing with selective catalytic reduction, or SCR technology, and how the complexity of this solution poses numerous issues for vehicle owners. Next, we'll discuss the in-cylinder solution that Navistar will be providing with our MAXXFORCE engines. We'll show you how the MAXXFORCE solution is a simple and smooth transition, providing full compliance while maintaining payload and service continuity. So let's get started. Selective catalytic reduction, or SCR, addresses NOx after it is formed in the engine. Reducing NOx after it is formed is a complicated process, which involves extra hardware that needs to be designed onto the vehicle chassis. More importantly, additional fluid will be required to meet the new emissions regulations, adding extra weight and requiring extra steps for the driver to maintain the system. But before we get too far ahead, let's take a look at the hardware. We installed an SCR system onto one of our engineering vehicles and painted the components yellow so that you can visually see the complexity of the setup. That's quite a bit of additional hardware. The reason for all the hardware is the SCR system requires an additional tank for holding urea, which we'll get to in a second, a urea catalyst, and a dedicated electronic control system and harness. In addition, a series of pipes, heat shields, brackets, sensors, heater. That's a lot of extra equipment, adding 300 or 400 pounds to the vehicle. This additional weight reduces payload, something to consider, especially for businesses that haul heavy materials and need every pound out of their trucks. We mentioned it earlier, but now let's get back to the urea tank. Urea solution is the reduction agent that, when mixed into the exhaust stream over a catalyst, helps break down NOx into nitrogen and water vapor. This is how our competition is going to meet the EPA requirement. Oh, and did we mention the added weight of a full tank of urea? 100 to 150 pounds. That's not counting the additional 300 to 400 pounds to additional components already added. There goes more payload capacity. Urea itself requires a lot of attention. A urea tank must be well insulated to prevent decomposing in hot climates and heated to prevent freezing in cold climates. So customers in all areas of the country will have to make adjustments, interrupting their daily business. And to complicate things further, currently there is no delivery infrastructure in place to distribute urea in North America. How readily available urea will be is not known, and vehicles with SCR requiring urea will not be able to operate if the urea level in the tank dips below a specified and regulated level. If there isn't enough urea in the tank, the engine will be programmed to derate and lose power, which will no doubt cause schedule disruption and inconvenience. Or, in plain English, without urea, your vehicle won't run. With SCR, every vehicle in your fleet will essentially have 2 fuel tanks. And all this comes back to the vehicle owner: the additional costs, the additional concerns, and the additional inconvenience. Next comes the question from the truck equipment manufacturer and bodybuilder. What do they have to do to engineer their bodies on a chassis that has extra hardware required for an SCR system? The answer is as complex and varied as the packaging and space required for using an SCR solution. The SCR system takes workable space away from TEMs, making them re-engineer controls, sensors, harnesses, and electronic interfaces for all applications. And that's going to add costs. Another important note: SCR systems, in addition to the hardware just discussed, also need to use an EGR system. SCR after-treatment systems are only 80 to 85% efficient. EGR is still needed and used with SCR systems. Proponents of SCR will tell you that despite all these disadvantages, using urea can increase fuel economy. That's true, in theory. And that theory is advanced by US OEMs based upon what has happened in Europe, where emission standards are not as stringent as 2010 standards here in North America. However, base fuel economy gains offered by SCR in a North American EPA-regulated environment will not be the same as the European experience. Because urea is used at a rate of 2 or 3% of diesel fuel consumed, and if urea sells near the price of diesel fuel, the cost of operation is equivalent when you factor in the need for a second fuel. The cost of urea right now in North America is slightly less than diesel fuel. In Europe, where urea use is increasing, the price is also increasing, dramatically. The quality of urea for automotive use must meet a very high level of purity and may not be substituted with urea used in agricultural applications. And that's not even factoring in the loss of payload in certain truck applications. So how is SCR an advantage? It's not. It's complicated and it's an unnecessary headache. That's why Navistar is taking a different approach. Let's take a look at all the additional components our MAXXFORCE in-cylinder solution will add to our chassis. There are none. Navistar's strategy is to prevent NOx from forming in the engine in the first place. This in-cylinder approach is key to Navistar's 2010 solution. We've eliminated the need for complex after-treatment hardware and procedures, simplifying the way to achieve compliance. So, how can Navistar achieve full 2010 compliance without aftertreatment when all other engine makers have opted for a more complex system that puts the burden of compliance on vehicle owners? How can Navistar stand alone on this challenge? The answer is Navistar has been planning for this, following a strategic path toward an in-cylinder solution for 6 years. 4 technologies enable us to differentiate ourselves from the industry: advanced fuel injection technology, proprietary combustion bowl designs, advanced air management, and electronic calibration strategies. One of the keys to in-cylinder elimination of NOx is advanced high-pressure fuel injection. Not all engines can handle the necessary pressures. Navistar's MAXXFORCE engine platforms, though, have been engineered well ahead of 2010 for high structural strength. MAXXFORCE's robust and durable block and head designs allow Navistar to achieve in-cylinder emissions reduction. This is proven technology that provides simplicity for customers. With Navistar's solution, there is no need for any infrastructure changes, any radical hardware additions, or any additional fluid. Service technicians are already trained on the systems, unlike SCR, which will require driver and technician training to service the system. And TEMs won't have to re-engineer bodies and functional components to accommodate new hardware and packaging. Navistar has manufactured nearly 1 million engines using these basic technologies since 2004. They are mature technologies that allow us to achieve 2010 emission standards with no negative impact on cost of ownership. The same confidence customers have in today's international trucks, IC buses, and MAXXFORCE engines will carry forward in 2010 with a proven in-cylinder solution with advanced EGR. This effective technology that is well understood and accepted in the marketplace is simple to maintain and provides peace of mind with business as usual for our customers. Navistar believes the burden of emission compliance should be with the manufacturer, not the customer. Before we conclude, let's take one last look at differences between SCR technology and the MAXXFORCE in-cylinder solution. Fuel economy is even. Both are fully EPA compliant. MAXXFORCE offers lower operating costs, no urea required, infrastructure or refill hassle, no payload penalty, no new service or driver training required, no impact on TEMs. The evidence is pretty overwhelming. Simplicity or complexity? With the 2010 emission standards approaching, it's your choice. One road, it's business as usual. The other adds complexity to your business. Our customers prefer simplicity. They rely on their vehicles as tools that need to work every day, every time they turn the key. They have deliveries to make, job sites to work, loads to haul, passengers to transport, and schedules to keep. Adding more work for them is something Navistar will not do. So as 2010 approaches, you should look no further than Navistar in our line of international trucks and IC buses powered by MAXXFORCE engines for your commercial vehicle needs.